All right, I was going to talk here about helping with some of the practice problems from 6.1. First of all, I think I stressed this in class last week a lot, but not as much on the video. Remember, an inverse is when you are interchanging x and y. So like if I have a point on a graph that's like 2, 5, if I say what's a point on the inverse, you just interchange x and y. So that would be a point like 5, 2. That's really all an inverse is. You interchange x and y. So on the practice problems, that's what 1 through 4 are basically all about. And so it's key there is like, remember the domain is the set of x's and the range is the set of y's. So if I have the domain of a certain function, and now I start talking about the inverse of that function, well, if we're going to interchange x and y, the domain of the original function, when we switch x and y, becomes the range of the inverse function. And the reverse is true. If I have the range of the original function, when I interchange x and y on my inverse function, that will become the domain. So on questions 1 through 4 on the practice problems, that's a key thing to remember on those. On the second set, they're on 5, 6, and 7. Those answers are all going to come from that table that I put on your thing. Like the first one says, y is the inverse sine of x. So if you look at that on this table over here, if you look at this first column, it lists all the inverse trig functions. The second column is the domain. The third and fourth columns are the range. So like if I was doing inverse sine, the domain is here, -1 to 1. The range is right here, -π/2 to π/2. So you can find any of the inverse functions from that. The third question they asked was increasing or decreasing. Well, you get that from looking at the graph. Like up here, this is inverse cosine. Well, to see inverse cosine is decreasing. That's all you have to do for that. So that's what you do on 4 through 7. Right? Then on the ones below that, 8 through 15 are very similar, except 8 through 11, those your answers should all be in radians. One, it says in the instructions, but also when it says y equals, that's radians. 12 through 15, those are in degrees because it says theta equals. So whenever you see y equals, that's radians, theta equals, that's degrees. So if we work some problems from there, like let's say we work number 11. Number 11 says y equals the arc cotangent of negative radical 3. So remember that means what angle has a cotangent of negative radical 3? So we're trying to find an angle. Y is an angle. Now first, since this is negative, we look at that table I gave you where it says here, like if you look for inverse cotangent is negative in quadrant 2. That's what it's saying here. So all these are where those are negative at. Remember, 3 of them are negative in quadrant 2, 3 of them are negative in quadrant 4. So this one, inverse cotangent, is negative in quadrant 2, so we know that. So when we graph it, we draw our triangle. Let's draw it in quadrant 2. We know cotangent is adjacent over opposite, so that's adjacent over opposite. Is that one of our triangles? Well, yeah, that's a 30, 60, 90 triangle. The angle opposite 1 is 30 degrees. Since we're in radians, that's our reference angle, is π/6. Now we want this whole angle, that's our answer, this whole angle. Well, all the way around here is 1 pi, which is 6/6. Back 1 is 5/6. So that's our answer. If we did one like 14, 14 says theta equals the arc sine. Remember, arc sine is the same as inverse sine. Means the exact same thing. So this says what angle has a sine of negative radical 2/2? Well, again, it's got a negative. If you look at that chart, inverse sine is negative in quadrant 4. Remember right here, they're all positive in quadrant 1. This tells you where they're negative at. So they're negative in quadrant 4. So when I draw that, I'm going to draw it in quadrant 4. And it says, what angle has a sine of negative radical 2 over 2? So sine is opposite over hypotenuse. Now this doesn't necessarily look like one of our triangles, but it is. If you did the Pythagorean theorem, this side would be radical 2. So this is the same triangle as 1, 1, radical 2. So this is a 45, 45, 90 triangle. So here, since it says theta, we're in degrees. Here our reference angle then is 45 degrees. Now remember, when you state that angle, you have to go the shortest way. You can't go all the way around like this. That answer is incorrect. Because remember, if you look at our range, our final answer needs to be between negative pi over 2 and positive pi over 2. In degrees, that's from negative 90 to positive 90. Well, this would be 315. That's too big. But if we just went this way, I always think go the shortest way. It seems shortest to go from here right down here. Well, that's a negative 45 degrees, and that's the answer. To me, it'd be a lot longer to go all the way around here when why not just go right there? That's the correct answer, the only correct answer. If you put 315, it would not be correct. All right, let's look at 15. 15 is theta equals the inverse cosecant of negative 1. Well, if we draw that, cosecant is negative in quadrant 4. If I draw that in quadrant 4, let's say cosecant is hypotenuse over opposite. So the hypotenuse is 1 and the opposite is negative 1. Well, that's impossible because the leg and the hypotenuse can't be the same length. So this is one that's not a triangle. Remember, when it's not a triangle, it's one of the quadrantal angles. If you think of our quadrantal angles, it's one of those 4. Well, cosecant is also r over y, so that's 1 over negative 1. So we're looking for where does y equal negative 1? Well, the only place y equals negative 1 is right down here. So this angle right here is the one we want. Well, that's at negative 90 degrees. Okay. Then, using your calculator, the ones there, 16 through 19, there you're using a calculator. Now, ones like number 16, you're just going to punch that into your calculator. You'll just hit second, then cosine, then that negative 0.1335. You just do it straightforward, just like that. That should give you the answer. Make sure you're in degrees on that one. The ones like 17 are a little tricky. It's the reciprocal functions that are tricky. 17 says theta equals the arc cotangent of 1.7670. Now, normally you would say, okay, just plug it in. You'd hit second cotangent, but we don't have cotangent on our calculator. So the first thing we have to do is change that to tangent. Remember, this says what angle has a cotangent of this. So this is our cotangent. Well, cotangent is the reciprocal of tangent. So if I want to change this is a cotangent right now. If I want to change it to a tangent, I take the reciprocal of it, like that. So now this is what you want to punch into your calculator. You'll be tempted to put this inverse tangent down at the bottom, but it goes out front like this. Because now this means what angle has a tangent of this. So on your calculator, you would hit second tangent and then punch that in. So if I do that on my calculator, see, I want to make sure, check my mode. I want to be in degrees. So now we're just going to punch that. We hit. So you hit second tangent and then 1 divided by 1.7670. And I get 29.50 rounds up to 7. So that's my answer, 29.507 degrees. So it's the reciprocal ones that are tricky. You have to change it to the reciprocal first, then do the inverse function. Let's do one more. Let's look at number 20. Number 20, I think these look harder than they are. we're finding the tangent of the arc cosine of 3/4. So let's look at this part. I think of this as the inside part inside the parentheses. Let's use that to draw a triangle and fill in the sides. Its inverse cosine is positive. Well, everything's positive in the first quadrant. Cosine is adjacent over hypotenuse, so adjacent over hypotenuse. Now to find the missing side, Pythagorean theorem says we take 16 minus 9 is 7. So this side is the square root of 7. So we use that part inside the parentheses to draw that triangle and fill in the sides. Now we're going to use that triangle to find tangent. Well, tangent is opposite over adjacent, so our tangent's just radical 7 over 3. So that's just a few representative problems that we picked out of section 6.1 that might help you. Okay?